Hello, good evening, all of you. Welcome back to our organic live session. This is our third day, and I hope you can see me and hear me clearly. Yes. So, what we are going to do today, actually, in the first 2 days, we completed IUPAC nomenclature part. First day, actually, I got the introduction for organic chemistry. Then we started nomenclature, but we could not finish that one within the first day. So that's why we had to do another day to complete a UPSC nomenclature. So we completed all the theory regarding the IUPAC nomenclature part. But then just completing theory is not enough. To understand the concept properly, definitely we have to discuss some questions also. Because through the question, we are revising the theory, then only you can understand it properly. I hope you are ready. But this time I got late to share the link. Maybe then some of you could not complete the homework sheet. Today I will discuss some questions from the homework sheet, and I will discuss some questions from the past papers also. Right? So it's okay whether you could finish that completely or not, because today through the question I will show you how to apply that theory. That is my main target. But other than that, I will not discuss I will not discuss these things completely, right? I will not discuss nomenclature. All the questions given in the tute, I will not discuss. I will give them. I will give key answers for these things. Okay, everything okay? Ne? You can see me and hear me? I hope you can hear me and see me clearly. Right, let's continue. But the thing is this one. Before I start the question discussion, maybe you remember I discussed all the classes: alkane, kene, kyne, aldehyde, ketone, carboxylic acid. So likewise, I discussed how to name all the classes, but except two classes. I don't know whether you notice it. No one asked me. One thing is ether. The other thing is nitriles. Ether and nitrile we didn't discuss. Actually, even in the resource book, the systematic name of ether and nitriles were not given. Those are not given. How to name ether systematically, how to name nitrile systematically, it's not given. But is given actually the common names. We can say a kind of trivial name. Okay. Common names are given. So then today I'm going to show you those things also. How to name this ether and nitrile, not then in a systematic way. Let's try to do systematic part also. Then you will understand definitely. Right. This is then before I go to questions, I will talk about these things: ether and nitriles. Ether and nitriles. How to name ether and nitrile? Better you know something about this one. Ether can be represented like this, ROR. Nitriles can be represented like this, RCN. R is the alkyl group, which has then only carbon and hydrogen. You remember that one? So once you have ether, how to name it? I take some examples and then explain. Once you have CH3 CH3O CH3. You see, this is ether. Ether having only 2 carbon atoms. Once you think about, I mean, once we discuss, then common name for this one. Common name is like this. There is one methyl, there is another methyl, 2 methyl groups. Therefore, we take it like what? Dimethyl ether. Dimethyl ether. But what if you are given 2 different alkyl groups like CH3O, CH2, CH3 like that? So if you are given 2 different alkyl groups, how we write the name of this one? We have methyl here, we have ethyl here. We write ethyl part first, E. So this should be ethyl methyl ether. This is the way we write the name. So if you have 2 different alkyl groups, name them, but see the alphabetical order again. So this is methyl, this is ethyl. So this should be ethyl methyl ether. This is how we write the name of ether. This is the common name of ether. But you know, then there is a systematic way to name this one. But in that case, you should consider, or you should take this OR part as a substituent. By taking OR part as a substituent, we can write the systematic name of this ether. But if I take OR part as substituent, what could be the name of that substituent? When you consider OR part as substituent, generally we write it like alkoxy. If you consider OR together as a substituent, the general name of this substituent, alkoxy. I can give some example, like if it is OCH3, 1 carbon atom. You know, it is alk. There is 1 carbon mean meth. Then oxy, methoxy, methoxy. This is the name if you consider OCH3 as a substituent. Then what if you are given OCH2CH3? This is as a substituent. Then there are 2 carbon atom. Then suffix should be what? Eth. Ethoxy, ethoxy. This is the name if you consider OCH2CH3 as a substituent. So likewise, we have propoxy, butoxy, like that. Then when I consider a compound like this, CH3, CH2, CH2OCH3, you see? If I consider it like this should be methyl propyl ether, the common name. It should be methyl propyl ether. There is 1 methyl group and propyl group. So methyl propyl ether is the common name. But if I want to write the name of this systematically, I consider this part as a substituent now. Because you see, in this alkyl group, there are 3 carbon atoms. So in this alkyl group, you have only 1 carbon atom. Then the one which has more carbon atom should be the main carbon chain. So therefore, this is identified as the main carbon chain. But this one then substituent. This one is considered as substituent. Then we need numbering. This main carbon chain can be numbered either starting from this end or this end. But, you know, we should give the priority to functional group. Here, actually, we consider this as a substituent, not as a functional group. Then next, we have to give the priority to double, triple, but there is no double, triple. Then we should go to substituent. Then once you consider or give the priority to substituent, this is your substituent. Then this is where you give number 1, because priority should be given for the substituent. Then 1 OCH. So this is how we have it. Then I told you the name of this substituent is methoxy, but that is attached to the first carbon atom. So we write it like this: 1 methoxy. Thereafter, root name. In the case of root name, there are 3 carbon atom and saturated compound. If there are 3 carbon atom and saturated, you know what to do. I mean, 3 carbon mean prop. Saturated mean we add AN. In this case, actually, it's an alkane, so we don't do that one. I mean, here, look at this one. when you write the name of ether, systematically, not the common name, systematically, you consider it as a derivative of alkane. Therefore, the suffix due to the functional group should be ane, alkane. But in the case of alkane, alkene, alkyne, I did not discuss adding an part. Maybe you remember I told you from amine onwards. From amine onwards, an is added if the compound is saturated, but it's a simple rule we discussed. Since we consider this as a derivative of alkane and we name it as ane suffix, no need to add an, right? I made a mistake in the previous case. So therefore, this is prop. Because this is alkane. OCH3, ketone part, ether part, we consider it as a substituent. Therefore, this is an alkane. So in the case of alkane, root name, we just write the name of stem name. Actually, we write a stem name, 3-carbon prop. Thereafter, we write the suffix due to the functional group. In alkane, it's ane. So this is 1-methoxypropane. That is the systematic way of this ether. But in the resource book, it's given only the common name. How to name ether commonly, in general. So common name is like this. But there is IUPAC name, systematic name is there. In that particular case, OR is considered as substituent, then general name alkoxy. But if there is 1-carbon methoxy, 2-carbon ethoxy, so that's how we name it, as a substituent. Then we follow the normal order. But again, you have to keep that in your mind. Once you name ether systematic way, we consider ether as a derivative of alkane. Then the suffix due to the functional group should be A. And then this is substituent, methoxy. It is attached to first carbon, then 1-methoxy. Root name, the first thing, stem name, name, suffix due to the number of carbon atoms. Since the 3, it should be prop, not propan. Propan is from amine onwards. This is alkane. That's why I keep it like prop. Then the suffix due to double triple, no. Then the suffix due to a functional group, since it's alkane, so A. So this is the name, 1-methoxypropane. Got it? But once I go to the past papers, when you go to last 10 years, so last 15 years, ether is not given as a question. Maybe that is why then it's not explained even in the resource book. That will not be expected to give in the exam, right? But if it is given, it's okay. This is the way. Then I don't go to then quite advanced example under ether, since it's not then given in the resource book even. No need to go to advanced questions there. Got it? Ether nitrile. In the case of nitrile also, I will explain that one in the same place. Once you have a nitrile, the functional group CN, CH3, CH2, CH2, CN. Then look at how many carbon atoms available, total number of carbon atoms. So how many carbon atoms available total? There are, look at this, even this carbon is counted, right? This is first, second, third, fourth. There are 4 carbon atoms. If there are 4 carbon atoms, you know the suffix. It is but. Again, we consider this as a derivative of alkane. Therefore, the suffix due to the functional group ane, butane. Okay. So therefore, it's butane, but since it's nitrile, we add suffix at the end, nitrile, butane nitrile. This is how we name nitrile, butane nitrile. So if you have this type of thing, so what could be the name? CH3CN. CH3CN. Here, how many carbon atoms are there? 1 and 2. If there are 2 carbon atoms, what's the suffix or stem name? It's eth. Eth plus ane, ethane, but it's nitrile. Therefore, ethane nitrile. No space here. It's ethane nitrile. That's the common name again, right? But there is another way to name this nitrile by considering CN as a substituent. By considering CN as a substituent, we can write the name of this one. So once you get CN as a substituent, the name of that one, it is cyano. We take it like cyano. There is no space to explain. I can take one example. I take it like this somewhere here. I take some other functional group like CH3, CH, CN, CH2, COOH. Like, look at this one. Once you have CN with another functional group, now CN is substituent. Once CN is substituent, you know how to name it. It is cyano. Substituent name is cyano. But then once you name this compound, go to the first step. So what's the first step? Identify the class. It's a nitrile, it's carboxylic acid. But carboxylic acid has the highest priority. Therefore, we identify this as a carboxylic acid. Then in carboxylic acid, I told you number one, always that carbon. Then start main carbon chain like this. 1, 2, 3, 4. That's the way we have. Then I ask you to identify this CN as a substituent, and the name should be cyano. Cyano. But that is attached to third carbon. Therefore, this should be 3-cyano. That should be 3-cyano. Then we write the name. First of all, we write the name of substituent. It's 3-cyano, only one substituent. Thereafter, we go to the root name. There are 4 carbon. Now it is butane because it's saturated. And from amine onwards, I ask you to add AN if it is saturated. So therefore, 4, it's butane. But then we go to double bond, triple bond, not available. Then suffix due to carboxylic acid. Then you remember that it's oleic acid. We learned that one. 3-cyano butanoic acid. That's the IUPAC name of this compound. I write it here because I don't have space. 3-cyano butanoic acid. Today, I don't explain that in detail because that day I explained everything, all the rules and everything in detail. Therefore, I don't explain that in detail. Everything goes smoothly. Got it? What I try to explain in this section, ether and nitrile, but in the resource book, ether and nitrile given, only the common names are given. Then in the case of ether, how to name it, how to give the common name? Ether, there are 2 alkyl groups always, oxygen, then ROR, 2 alkyl groups available. Then we take the name of these 2 and see the alphabetical order. But if you have 2 alkyl groups of same type like this, we don't write methyl ether. We use then the prefix di. There are 2, then dimethyl ether. But if you get 2 different groups like this, one is methyl, the other is ethyl, then we see the alphabetical order. So it should be ethyl first. Ethyl, methyl, ether. That's the common name. In the case of nitrile, the common name is, you look at the total number of carbon atoms available in the main carbon chain. Here we see 1, 2, 3, 4. Then we write it like alkane, like butane. Ane is the suffix we use here. Here also we use, then here we don't use ane, but here we use ane. But when you write IUPAC name of ether systematically, definitely we take ane, derivative of alkane. So nitrile, then we write, there are 4, then butane, because of its nitrile, butane, nitrile, methane, nitrile, ethane, nitrile. There is no methane, nitrile. Ethane, nitrile. 2 carbon atoms should be there, at least. Ethane, nitrile, propane, nitrile. So that's how we write the name. But there is another way to write the name of ether. In that case, we take OR group as a substituent. But once you take OR group as a substituent, if this is substituent, then there should be class of compound. The compound is identified as an alkane, So therefore, ether, in this case, ether is a substituent of alkane. Then OCH3 group, the names I gave you, methoxy, ethoxy. Even you can manage it very easily. That is attached to first. Then 1-methoxy, since it's alkane, we discuss how to name alkane. 1-methoxy propane. Even CN can be considered as a substituent if there is another functional group. In that case, CN substituent, the name is cyano. Then we follow the normal rules we discussed so far, and then write it. Got it? This is the way we name ether, and this is the way we name nitrites. I hope you understood. Any doubt you have, then you can just send me that one through chat. Shall we have a small note regarding this one? Let's have a note regarding this. Copy these two, this topic, ether nitride, and show this ROR and RCA. Ether nitride. Then write it like ROR and RCA. This is how we represent the functional groups, the classes. Then write it like this. In general, write it like this. In general, the common name of ether is written. In general, the common name of ether is written. In this case, both alkyl groups are named. Both alkyl groups are named, and ether is added at the end. In this case, both alkyl groups are named and ether is added at the end. Ether is added at the end. Okay, now copy these two examples. Dimethyl ether and ethyl methyl ether. You can understand why I put dimethyl. No need to give that one to the note. You can understand it. Since we have two alkyl groups of same type, so that's why we use di prefix. Okay, better you copy these two examples quickly. Okay, copied. Below that, we write it like this. Next, write it like this. There is another way to write the name of ether. There is another way to write the name of ether. There is another way to write the name of ether. In this case, OR is considered, this part, OR. In this case, OR is considered as a substituent. In this case, OR is considered as a substituent. And then it is named, as an alkane. And then it is named as an alkane. Okay, let's go for this example. Copy these things. First of all, copy OR, then substituent, then name alkoxy, the general one. But examples OCH3 methoxy, then copy this, and thereafter copy this example, 1-methoxypropane also. You have to copy this part. Okay, I hope you copied it. Then let's write this one. Start a new point and write down. Nitrile can be named. Nitrile can be named in two ways. Nitrile can be named in two ways. Two ways. In the first method, nitrile is used as the suffix. Nitrile is used as the suffix due to the functional group. Nitrile is used as the suffix due to the functional group. Then copy these two examples. Butane nitrile and ethane nitrile. So I think you notice that here it is special. We consider carbon atom even in the CN group. Then that's how it becomes then 4 carbon atoms here and butane. Then write it like this. 1 Next, right? In the second method, CN group is considered as a substituent. In the second method, CN group is considered as a substituent, and it is named using cyano suffix, and it is named using cyano suffix. Okay, let's copy this example then. Good. So, yeah, then that's everything regarding the nomenclature of organic compound. Now, if I give you any compound, you should be able to name it correctly. I hope you have that confidence. Got it? But before I then move to, again, question discussions, I want to discuss one more thing here. Thereafter, I can go to screen sharing and then share the homework sheet and finally discuss the questions. Before I go to that, I told you I have to complete one more thing. What is that? The reverse is also there. Sometime you are given the IUPAC name, but you are asked to write the structure. So far, what I explain how to name if the structure is given me. But sometimes the reverse is also there. They give the name. IUPAC name is given. Then you are asked to derive the structure. How do we do that? With this knowledge, actually, all of you can manage that question also. But if I just show you by taking at least 2 examples, there is no separate theory for this one. From the theories we discussed so far, using the rules we discussed so far, we can take the structure according to the name. You all can understand it. I take one simple example like this. Let's take, yeah, what is it? I take 3-bromo, let's say butanoic acid. 3-bromo butanoic acid. I took simple one because then it is easy for me to deliver the concept. 3-bromo butanoic acid, the IUPAC name is given. You are asked to get the structure for this one. I told you then this name has complete information regarding the compound. What's the functional group? How many carbon atoms in main carbon chain? How many substituents available? What are the substituents available? What are the positions of substituent? Whether the compound has a double bond, whether the compound has triple bond. So everything is there. But in this case, I can then explain it in this manner. First of all, go to this suffix, stem name, and see how many carbon atoms available. Since butane, how many? 4 should be there. Right. I told you then here, I assume you know nothing about UPSC nomenclature. Based on that, I will explain all these things. But I know some of you already know all these things, then nothing to worry about that. It's completely okay. First, we go to this suffix, stem name, suffix due to the number of carbon atom. Thereafter, see the functional group. Oic acid mean it should be carboxylic acid. There, I gave you 5 classes. Carboxylic is one of that one. If you have carboxylic acid, if you are given carboxylic acid, number 1 always goes to what? Carbon in carboxylic acid group. So therefore, I take this one. Or even you can consider this one. Doesn't matter, right? But here I take this is carboxylic acid group. I mean COOH group. Then number 1 goes to this. First, you go to stem name, see how many carbon atoms. Then you go to the suffix due to functional group and identify the class of the compound. Thereafter, you place the functional group. So in the case of carboxylic, amide, ester, acid halide, in these cases, then number 1 goes to always that functional group. But in the other functional group like alcohol, amine, ketone, we can't say it's number 1 always. But in that case, this will be given, the number given to all like that, it's given. Then you see that position and then place the functional group. Okay, right. Next, you go to the substituents. Thereafter, you go to substituent. Just remember the order. Stem name, functional group, and then substituent. That is where we complete it. Then before that, we have to number it. 1, 2, 3, 4. This is how we number it. Third place, you have bromine. Then third carbon atom, there should be bromine. Sorry. Now it's okay. But to complete this one, you should add hydrogen. Until the valency of carbon becomes 4, you need to introduce then hydrogen. You know, this carbon should have 2 more. This carbon should have 1 more. This carbon should have then 3 more. This should be your compound. So when I write it in a condensed formula, it's this way. Condensed structural formula, it should be like this. If you are not sure, you can name it again and see whether you end up with this name. If you have get the structure correctly, then no issue. You should definitely get this name again. You know, then this is carboxylic acid, 1, 2, 3, 4, 3 bromo, butanoic acid. Got it? So that's the way we get the structure if you are given name. Let's go to one more. Just one more. One more example is enough because I will discuss more example under homework sheet. Another example. So what could be that? Let's take it like that. I take, 1, 2, 3. 3 amino. Pent 2 on. 3 amino pent 2 on. Pentan 2 on. 3 amino pentan 2 on. 3 amino pentan 2 on or 2 pentanol. But I have given it like 3 amino pentan 2 on. Then what's the first thing you should consider? The stem name. How many carbon atoms? Pent mean there should be 5. Okay. Thereafter, you go to the functional group, on. You know, on suffix is for what? Ketone. Then this should be ketone. Ketone, the functional group, C double bond on. Then where do you find that functional group? You find that one in the second place. Second place you find. You can number it from either this side or the other side. Let's say we number it like this. 1, 2, 3, 4, 5. Or from the other side. But second carbon, there should be ketone part, means C double bond O should be in the second place. Next one, you see, that's all. Thereafter, we go to the substituent. Just one substituent is available. It's amino. Third place, there should be amino. Okay, amino, you know, it's NH2 group. Third carbon atom, you have NH2 group. That's all then. Thereafter, you complete valency of carbon 4 by giving hydrogen. CH3, here 4 valence is satisfied. This has 1 hydrogen, this has 2 hydrogen, and this has 3 more hydrogen. This is your compound. 3 amino pentan 2 on. Yeah, this is the compound. Got it? That's easy, né? Then if this is not sure, again, you can name it back. Then you have to follow those rules. Identify the class, amine, ketone, but ketone has high priority. It's ketone. Then amine NH2 becomes substituent. Identify the main carbon chain. This is the only carbon chain available. That's the main carbon chain. Number the main carbon chain. Priority should be given to the functional group. Then from this side, you number it 1, 2, 3, 4, 5, 6, like that. 5. That's all. Then write the name of substituent, 3-amino. It is saturated one, so therefore it should be pentan. Then 3-amino pentan. Second place, you have own group, ketone. 2. Yeah, yes, we are correct. So that is how we get the structure if you are given the IUPAC name. I hope you got it. Right, let's go to the note regarding that one also. Let's have a note also. Ne? Write it like this. If the IUPAC name is given, the structure of the compound can be deduced or can be obtained. If the IUPAC name is given, the structure of the compound can be deduced. In this case, following order will be helpful. There is no certain order. Then I gave this order, then it's quite easy for you to get the structure if you follow that order. That's why I give it. The following order will be helpful to get the structure. Then write that order one by one. First thing. According to the stem name, the number of carbon atoms in the main carbon chain is identified. According to the stem name, the number of carbon atoms in the main carbon chain is identified. Second thing, identify the functional group. According to the suffix given at the end of the name. Identify the functional group according to the suffix given at the end of the name. Next one, third one. After numbering the carbon chain, the functional groups and the substituents are placed. After numbering the carbon chain, the functional group and the substituents are placed. Next thing, finally, hydrogen atoms are added to the structure. Finally, hydrogen atoms are added to the structure. added to the structure until the valency of carbon 4 is satisfied. Until the valency of carbon 4 is satisfied. Okay, then better you copy this one. Here first IUPAC name is given. Then you got the structure like this. Here also IUPAC name is given. Then you got the structure like this. Right. I hope you copied this. So that's everything regarding the nomenclature. Then complete theory we discussed. Next thing is, the purpose of having this third class is actually the discuss more questions. And I share the homework sheet. I hope some of you have completed the questions. But it doesn't matter whether you complete or not, because here I don't explain all the questions given in the homework sheet. I select some questions here and there and then explain how to get the answer. Thereafter, I will share the key answers for this homework sheet. For all the questions, the answers are given. I'll share it, right? But those who want that answer sheet, definitely you should drop a WhatsApp message to me. Then through the WhatsApp, I will share the key answers for this, for all the questions given in the homework sheet. Okay, right. Now, yeah, it's time to go to the homework sheet and then discuss some questions here and there and finish this part. But homework sheet, then if I use in this manner, then I have to write the structure again and then do everything. It's time wasting. Then I supposed to do the screen sharing part. But for that, I need about some time, small time interval to arrange these things, to connect the notepad and everything. Yeah, then give me about 3-4 minutes. Until then, I will share this. right? Let's go to homework sheet 1 and then discuss it. I hope you can hear me. So can you hear me properly? I hope you can hear me, and yes, you can see the screen also. Ne? Right, this is our homework sheet 1. Once you go to the first question, you see the question is identify the main carbon chain and number it correctly in the following organic compounds. That's the question. But once I go to they has to number it correctly. Ne? Correct. Let's take these two examples. I mean, several examples I will consider, but I told you I'll give you key answers for all these things. Once you consider the first compound, so what do we have here? First thing is to identify the functional group. So what is the functional group? Since alkyne, I mean triple bond is there, you identify this as alkyne. Triple bond is there, therefore it's alkyne. Then when you number it, no need to then worry about the main carbon chain because this is the only carbon chain available. Therefore, this should be the main carbon chain. Then once you number it, you know what to do. In that case, we number starting from the functional group side. Then this should be number 1, this should be number 2, this should be 3, 4, and 5. So this is the correct main carbon chain and correct numbering. Then I draw bypass second one and go to the third one. Or let's say fourth one. In the case of fourth one, you identify the class of the compound. So what is the class of the compound? It should be definitely carboxylic acid because of this COOH group. It should be carboxylic acid. Then in the case of carboxylic acid, I told you then it is very easy to identify the main carbon chain and number it. Definitely the main carbon chain should be this one. Starting from this carbon, we move up to this one. There is no any other option for this. That's the only option available. So it should be the main carbon chain. Now, when you get the number in carboxylic acid, I ask you to keep always this carbon number 1. This is 2, this is 3, this is 4, and this should be 5. Then this becomes what? Substituent. Cl becomes substituent. OH becomes substituent. So in the fourth case, this is how we have main carbon chain and the correct numbering. Don't worry, I will share these things. Then I go to, let's take these things. I mean, again, carboxylic acid, no need to get it. Go to sixth one. Let's try the sixth one. In sixth one, first we identify the class of the compound. Since it's OH available, Br available, then OH available alcohol, Br available, it's alkyl halide. So since OH has high priority, we identify this as what? Alcohol. This is alcohol. Then this is your functional group. It must be in the main carbon chain, but we should start main carbon chain from one of this end. Therefore, I should start from this carbon and go up to this. You know why I didn't consider this one? I didn't start from that carbon. The reason is, you know, there is a substituent, I mean Br, there is substituent Br in this carbon. Then more substituent should be available. That is why I start from that carbon and go up to the final one. Then the numbering, once you number it, one can number from this end 1, 2, 3, 4, 5. But one can number from this end 1, 2, 3, 4, 5. Then we give the priority to what? Functional group. In the case of functional group, there are two options now, 2 or 4. So which one is correct? The lowest possible number, 2. So because of that, you can see red one is wrong. Red one is wrong. It can't be the correct number in. Correct number in should be definitely the blue one. Lowest possible number. In that case, we have these things as substituent. Then whole group CH3 substituent, Br substituent, NO2 group is substituent, and alcohol OH group is identified as the functional group, not the substituent. Okay, that's how we identify the class and identify the main carbon chain and number it correctly. Let's go to 8th one and discuss it. First of all, the class, it's very easy, carboxylic acid, COOH available, carboxylic acid. Then once you select the main carbon chain, I ask you to start from carboxylic acid part. From this carbon, you come to this junction. Once you come to this junction, you have two options, go straight or go down. So which one is correct? Then down is good. Why? There is a double bond. Since there is double bond, your main carbon chain should be like this. Double bond has priority. I explained that one several times. So according to that theory, this whole group becomes now substituent. This is your main carbon chain. Numbering is easy because carboxylic part carbon has number 1, then number 2, number 3, number 4, 5, and 6. That's the way we identify the main carbon chain and number the main carbon chain correctly. So you can try the other compounds. I'll share the key answers. You can complete it. Okay, you see then second question. Second question is write the IUPAC name of the following organic compound. Then just find in the main carbon chain not enough. Number in the main carbon chain not enough. We should name it. How to name it? Again, we go to the first step. Identify the class in. I'm talking about the second question. This is, alkyl halides available, but I told you, halogens always considered as substituent. In that case, this is alkane. We identify this as alkane, not alkyl halide. Then the suffix due to functional group should be ane. You don't have a problem with the main carbon chain because it's just one available. Then that must be the main carbon chain. But numbering, you have to be careful. When you number it, you have to be careful because one can number it from this side 1, 2, 3, 4, 5. Or one can number from this side. Which side? Yeah, this could be then according to that. This is 1, this is 2, this is 3, this is 4, this is 5. Then which one is correct number in here? For the functional group BR, it's number 3. If you use then blue one. And for I, it's number 4, 3, 4. If you use green one, you see iodine has number 2, bromine has number 3. So which one is good? I mean, number 3, 4 or number 2, 3? Yeah, definitely you get the answer. Number 2, 3 is most suitable one. 3, 4, 2, 3, 2, 3 the lowest possible numbers. All right. Then we complete that one. We identify the class, we identify the main carbon chain, we number the main carbon chain. Then that part is okay. Next thing is to write the name. First of all, we write the name of substituent. One is bromo, the other is iodo. We follow the alphabetical order. Then it should be 3 bromo. Thereafter 2 iodo. And next we go to the main carbon chain, 5 carbon atoms, then stem name. And I told you, name this as alkane. In that case, it's just pentane, right? Pent, not pentan, pent. 3-bromo, 2-iodo, pent. Since it's alkane, we use ane suffix. Then we put this one here. 3-bromo, 2-iodo, pentane. That's the correct name for second compound. Got it? Then I take the sixth one and try to explain. In the case of sixth one, only one carbon chain available. That should be the main carbon chain. This is the main carbon chain. And we identify the class, it's alkyne. This is then alkyne. Triple bond available, so it's alkyne. Then in numbering, we should give the priority. Here you have I and Cl, but again, halogens. Those are substituents. Numbering, it should be from this side because for alkyne, triple bond 2, 3. 1, 2, 3, 4, 5, 6, 7. That's how we have it. If you come from the other side, the numbers, then not good. It can be then not 2, 3. Then if you start from this 1, 2, 3, 4, 5, 6, 7. You see? According to blue one, it's 5, 6. But according to red one, it's 2, 3. Yeah. Good thing is then, but 2, 3, it's lower than 5, 6. So this is the correct numbering. Now we move to the name. In that case, where you write the name starting with substituent. You have iodo and chloro. So what should be the one? It should be 5-chloro. 5-chloro according to alphabetical order. Thereafter 6-iodo. That's end of substituent. We go to the root name. There are 7 carbon and triple bond. 7 triple. Then we take it like hept. Not heptan, no hepta. It's hept. Next, the suffix due to the triple bond. So what do we get? Suffix due to triple bond. Sorry, it's ine. But I ask you to place, give the position of this triple bond. Then write number 2 because that is where triple bonds start. And then I ask you to add ine suffix at the end because of triple bond functional group. So it's 5-chloro, 6-iodo, hept, 2-ine. Then I ask this question again. Is there any other name for this? Of course, because this is your root name. Hept 2-ine is the root name. But inside the root name, you have one number, it's 2. Then I ask you to take it out. Take it out of the root name. Then hept 2-ine can be written like 2-heptine. So it's 5-chloro, 6-iodo. It's quite difficult for me to write the letters using this notepad because I didn't use this one for a long time. But I hope you can read still. So hept 2-ine can be written 2-heptine. Both of these two are correct names for sixth compound. You see how easy to name the compounds if you remember all the rules and stuff. Then here we have ether part. Then shall we name it? But then I told you when you name it systematically, ether part is considered as a substituent. Therefore, this OCH3 group is substituent. Name is methoxy. Then I start the main carbon chain from this carbon because OCH3 should belong to that one. But when you come to then this carbon, I mean, junction is there. You start from here, come to this carbon. Once you come to that carbon, you stop there. Two options available. One option is go straight, two more carbon atom, no double, no triple, no substituent, or go up. Then how many carbon atoms available if you go up? It is given C2H5. But don't worry, C2H5, once you display it, it will be like what? CH2, CH3. Sometimes they give CH2, CH3 in this manner also. But then you draw it displayed formula and you see there are only again two more carbon atom. Ne? Once you go then up like this, you add only two more carbon. No double, no triple, no substituent. Therefore, my point is this one. So either way is correct. You can go straight or you can go up. Either way, it's correct because in both ways, you don't meet any double triple. You don't meet any substituent. You don't meet any no substituent. Then definitely you can use then any of this. I mean, I go straight and name it. In that case, you see then this C2H5 whole group becomes substituent. Then what could be the number in? One can start this 1, 2, 3, 4, 5, 6. Hurry. Other can start from this side. I mean 1, 2, 3, 4, 5, 6. Then which one is correct? Red or green? Here you see OCH3 substituent takes number 2. Here you can see C2H5 ethyl group takes only number 3. Then which one is possible? Number 2 or number 3? As you can see, the lowest possible number 2. Therefore, green one is not suitable. Green one is not suitable. Because of that, we take red one as the correct numbering. Thereafter, we name it. Easy. What's the name of this? I told you. This is methoxy. Hari, OCH3 methoxy. This one is ethyl. 2 carbon atoms, alkyl group, ethyl. Then the alphabetical order, ME. E should be first. That is in 4th carbon atom. Then it should be 4-ethyl. Thereafter, you get methoxy group in 2nd carbon, 2-methoxy. And we go to the root name, it's an alkane. We name it as alkane. There are 6, then it should be hex, no space, hex, and A, hexane. Got it? This is the way we name this compound. 1, 2, 3, 4, 5, 6, yes. 4-ethyl, 2-methyl, 2-methoxy, hexane. You can check your answers, whether your answers are correct or wrong. If you have done it, you can check it. What else we try? Let's try an alcohol. 12th one. 12th one again, now a carbon chain easy, just one available. This is your main carbon chain. Before that, we should identify the class. Since our OH group here, this is the functional group. You know, Cl halogen, it's substituent always. Then OH functional group, so we identify it as alcohol. It's alcohol. Numbering. Then here, look at this one. One can number it from this side. 1, 2, 3, 4, 5. Number 3 goes to the functional group. One can number it from this side. 1, 2, 3, 4, 5. Again, number 3 to the functional group. Then if you get same number to the functional group, you know what is next. You go to the double bond, triple bond. That, but unfortunately here there is no double, there is no triple. Then it's okay. You forget it. Then you go to the substituent. Then now the thing is Cl part. Cl is the key factor now. So then according to Cl, there are two numbers, 2 or 4. But once you consider 2, 4, we need the lowest one. Then we easily identify the correct number in. It's the blue one. Number 2, that's lowest number for Ca. Right. Then numbering part is over. Thereafter, we write the name of these things. First of all, the substituent, it's 2-chloro. 2-chloro. Thereafter, stem name. There are 5 carbon. Now, don't forget this. It's pentan. Why? I told you from amine onwards, we add A if the compound is saturated. No double, no triple. Yes. Saturated. So, AN added pentan. 2-chloropentan. Then the suffix due to double, triple? No. Then suffix due to functional group OH, all. But can I just write all like this? No, it's wrong because the position should be mentioned. In the case of amine, alcohol, ketone, I ask you to give the position. So it should be pentan 3 all. Pentan 3 all. But as you can see again, within the root name, you have just one number. You can take that number out of the root name. Therefore, pentan 3 all can be like 3 pentanol. Then if I write it again, 2-chloro, 3 we took out and combine these two, then pentanol, pentanol. This is also correct name. 2-chloro, 3 pentanol. Got it? What else we write? Okay, shall we write the name of 13th one? 13th one, we write it like this. First class. So what could be the class here? Ketone, amine available, priority, ketone. So because of CO group, we identify this as a ketone. This is ketone. In that case, NH2 becomes substituent. You know the name, amino. Then number in 1, 2, 3, 4, 5, 6, 7, 8. Number 4 goes to the functional group. But one can check the other side. Number 1, number 2, number 3, number 4, number 5, 6, 7, 8. Then it's clear we have option 4 or 5. Then 4 or 5, 4 lowest number. Then we simply ignore green one, red, blue one is correct. Hurry. Yeah, that's all. Then we write the name. First, the substituent NH2, 6 amino. Then the stem name 8 saturated, then octan. Octa, but we add AN, octan. AN, octan. Then the suffix due to ketone, its own, but in ketone, alcohol, amine, position should be mentioned. So it should be what? 4 or 6 amino, octan 4 or. So remember, you can't drop one of this O. Some of you think 2 O's together, then shall we drop one O? You can drop, but your answer is wrong there. So is there any other name for this? Of course, within the root name, one number, then you can take it out. So you have another name for this. It's 6 amino. 4 out, then 4 octanon. Octanon. 6 amino, 4 octanon. Correct. That's the way we name that compound. Okay, then I go to 19th one. There is an aldehyde group. In the case of 19th one, first we identify the main carbon chain. We should start from that. Again, only one available. It's easy. In these cases, I told you then OH becomes substituent, Cl becomes substituent because aldehyde is the main thing. In aldehyde, I ask you to keep number 1 always to aldehyde 1. If you identify the class as aldehyde, then definitely that carbon number 1. Now it's easy. 6 chloro, alphabetical order, 6 chloro, 5 hydroxy. Now it's not 5 all, it's 5 hydroxy because OH is now substituent. 6 chloro, 5 hydroxy. 7 carbon. So what about that? Heptane or hept? I think you notice it. Now it's hept. Because double bond is available. It's not saturated. It is unsaturated. Unsaturated mean you keep it like hept. Next, suffix due to double bond. It is in. But the position should be mentioned. 4th carbon start in. Right. Normally in, you know, ENE. But here I wrote it like EN only. I think you remember that rule. If you add another suffix after E9, you drop the last D. Then it is EN, just EN. For EN, for EN, right. Next, the suffix due to functional group, you know, aldehyde, L. But here we don't mention the number because aldehyde always number 1. So it should be like this: 6 chloro, 5 hydroxy, hept, 4 enal. Any other name? Yes. This is your root name. Then within that you have one number. You can take it out. And it's another name. 6 chloro, 6 chloro, 5 hydroxy. And you take 4 out, either 4. Heptenal, not heptanal, it is heptenal, E. To represent double bond, we need that E, heptenal. Right, that's the 19th one. Yeah, I tried to take then different types of compounds and explain, then you have some idea. Again, write the IUPAC name of the compound. The previous one also same. Write the IUPAC name. Okay, these are, I think, some of past paper questions, maybe. Okay, what do we take? Here only one carbon. I take, okay, I'll take the difficult one. Before that, let's score this. We didn't name acid halide. First one. First one, acid halide. Class is identified. In acid halide, I ask you to start the main carbon chain from acid halide. Even in the numbering, I ask you to start from that carbon. This is number 1, 2, 3, 4, 5. You remember those 5 classes. These become then substituent. Yeah, then we write the name. Hydroxy and methyl. So which one is first? A, B, C, D, E, F, G, H, hydroxy. Ne? So it should be 4 hydroxy. It's very difficult to write the name. 4 hydroxy, 2 methyl. Next, the root name saturated 5 pentan. No space. Pentan. Then the suffix due to the functional group, it's oil chloride. Number 1 is not written in these. In those 5 functional group, we don't write number 1. 4 hydroxy, 2 methyl, pentanoil, space. Since it's Cl, it's chloride. There should be space here. That's how we name acid halide. Then I go to fourth one. Look at this. Fourth one, it's carboxylic acid because of COH group. But I took it like this because here CN is available. So it's a substituent. OH, substituent. Then number 1, number 2, number 3, number 4. Here O is also substituent. Ketone part is substituent. Then we consider O only. Then 1, 2, 3, 4. That's the way we have. Then 3 substituent, you get cyano, hydroxyoxo. Then it should be cyano first. 4 cyano, hydroxy and oxo. ChelMNO, then H should H. This is 4 hydroxy, 2 oxo. I told you then when ketone is substituent, it's just oxygen and suffix is oxo. Thereafter, root name stem for saturated butane. It's saturated, no double, no triple. Yes. Butane oic acid. Oic space acid. 4 cyano, 4 hydroxy, 2 oxo butanoic acid. Okay, next I take sixth one. Sixth one, it seems like quite complex, but it is not. Sometimes once you see a compound like this, you give up. It seems like very complex one, but it is not. Just follow the order. What's the first thing? Identify the class. Because of this, it's carboxylic acid. Whatever the functional group available, it's carboxylic. That has the highest priority. What is this actually? COH part? What is this? That is aldehyde. But aldehyde has less priority compared to carboxylic acid. So therefore, aldehyde group, whole group is substituent now. Because from the carbon chain also we identify that. You see, then when you select the carbon chain, we start with this carbon, carboxylic acid carbon, come to this junction. Then there are 3 options. What do? I mean, go straight. If you go straight, only this carbon. And substituent is there. Okay, this oxygen is substituent now. If you select this carbon as main carbon chain, part of main carbon chain, remember even in aldehyde, it's oxygen as the substituent, oxo. But if you go down, you see there is no substituent, just 1 carbon. If you go up, what do we have? You have double bond. Here, in this case, substituent available. Here, nothing, 1 carbon. Here also 1 carbon. But in this case, double bond and 2 carbon. Then what is the priority you should give? Definitely, we give priority to double bond. Therefore, definitely we should go up to select the main carbon chain. Understand? So in this particular case, the main carbon chain should be from here to here and from here to here. This is your main carbon chain. According to that, these becomes then substituent. Aldehyde group and CH3 group substituent. Numbering. Number one always carboxylic. Okay, then 1, 2, 3, 4, 5, 6. Then the name. First of all, we write the name. Now, whole group is substituent. In the case of this, you see, whole group is substituent, not only oxygen. It's whole group. Therefore, it's formyl. It's in fourth carbon. Therefore, it should be 4-formyl. This one is methyl, 4-methyl. Then 4-myl first. Then 4-formyl, 4-methyl. Then how many carbon? 6. Is this unsaturated? No, it is saturated. Double bond is available. So because of that, it's not hexane, it's just hex. And next suffix due to double bond, you know, it's in fifth carbon. Fifth carbon starts, it should be 5E. 5E. But next, lastly, I drop because I have to add oic acid. Finally, the carboxylic part, then oic space acid. 4-formyl, 4-methyl, hex 5-enoic acid. But as you know, then you can take this 5 out. Because just one letter, so it can be written like hex 5-enoic. You can write 5-hexenoic. 5-hexenoic acid. That's also possible. These things should be here. So you see, it seems like complex compound, but once you follow the order, nothing is then complex. Right. Let's go to 11th one. 10 and 11th one. I'll consider 11th one. It seems quite then sometime complex, but it's not complex, you see. Right. Let's go to this. I mean, first identify the class. I'm talking about this one. Alcohol, OH alcohol, triple bond, alkyne, then this is ketone. But according to the priorities, we know it should be a ketone. We identify this as a ketone. Then this is your functional group. Carbon chain, okay, because just one straight line is there. So we identify the carbon chain from here to here. Then these become substituent. OH group is substituent, CH3 substituent. That's how we get it. You know why I didn't go up here? I go straight here. Why? Because substituent is there. OH substituent is there. If you go up, you don't have any substituent. So that's why without going then here up, I go to straight. Then CH3 whole part becomes then substituent. Hurry. Next, the nomenclature. No, before that, numbering. One can number it from this side. 1, 2, 3, 4, 5. Number 3 goes to the functional group. One can number from this side. 1, 2, 3, 4, 5. Then again, be careful. Functional group has same name. I mean, same number. 3, 3. Then we go to the priority double triple. Then, as you can see here, this is where you get lowest number. Triple is between 1, 2. But according to blue, it is 4, 5. Which one is good? 1, 2 or 4, 5? Yes, it should be definitely 1, 2. Therefore, we simply ignore green numbering. Right. Now we are ready to name it. Hydroxy, methyl hydroxy first, 5-hydroxy. Thereafter, 4-methyl. Next in suffix due to number of carbon atom or stem name. There are 5 pent. No space between methyl pent. Not penton because it's unsaturated, triple bond. Okay, pen. Thereafter, suffix due to double triple. There is triple bond in first carbon. Then it should be ine, but drop the last E, just Y. But we can't just write YN because position should be specified. Position is what? First place. Then 1 ine. 1 ine. Next in, you get suffix due to functional group, its own. But where is it? Third place. I told you in ketone, you should mention the position. 3 on. It's not 1, it is on. 3 on. That's the name. 5-hydroxy 4-methyl pent 1 ine 3 on. That's correct name for 11th one. But then I ask this again. I mean, does this have another name? Is it possible to have another name? This is your root name. Inside the root name, there are 2 numbers. But the thing is, these are separated by ine. You see? There are 2 numbers, 1, 3, but not together, separated. In that case, remember, you can take the first number only out of this. Therefore, there is another possible name for this. You can take the first number only out. I think I mentioned these things when I explained the theory. So, there is another name, 5-hydroxy. And 4-methyl, you can read my handwriting. Since I didn't use this for notepad long time, it's quite difficult to control it. 5-hydroxy 4-methyl. Next, 1 pentine together, pentine. Thereafter, 3 on finally. You can't take both 1 and 3 out, and then say 1, 3 pentine on. No, that's not possible. If there are 2 numbers and separated, only the first number you can take it out. Got it? Yes. These are actually exam standard one. I think these are past paper. Don't know. I can't remember. So anyway, exam standard one. Okay, we completed 3. Then there are 2 more. Here also I'll discuss some examples and show you how to get the answer. Let's take the first one. Question is, draw the structural formula for the following IUPAC names. Sorry. Once the name is given to draw the structure, I ask you to first pay attention to this one, hex part. Hex means how many? 6. So we draw 6. And even you can number it. Ane mean alkane. Therefore, you can simply number it. Let's number it. I number it from this side. 1, 2, 3, 4, 5. It's okay. You can number from this side also. 1, 2, 3, 4 like that. But I use the other side. This is the numbering. Hurry. Then you go to the substitute and you see 3-ethyl. Third place, you get ethyl group. Ethyl means, third place you get ethyl. Ethyl means C2H5. Or simply you can write CH2CH3. Or you can put it like C2H5. Doesn't matter. Condensed formula for ethyl group. Third place, ethyl group. Right. And third place, you get methyl group also. And to the same carbon, there should be methyl group, CH3. That's all. 3-ethyl, 3-methyl hexane. But I asked you to complete these things with the hydrogen until valency of carbon 4 satisfied, CH2, here CH2, here CH2, and last one CH3. That's the structure for the first name. Next, I'm going to name alkyne. Fifth one. Okay. I take the fifth one and try to name it. Not name it, try to get the structure. First of all, we go to fifth one. Hex again. Hex. Hex means 6 carbon. Then we draw 6 carbon. Number it. Any side, use any end, you can start numbering 1, 2, 3, 4, 5, 6. Okay. Okay, then go to substituent. 4, 4, 5, 5. Tetramethyl. Methyl. CH3. Ne? Then fourth carbon has 2 because total 4. Ne? 4, 4 mean there are 2. Fifth one again has 2 because it's given 5, 5. Again 2. 4, 4, 5, 5 tetramethyl. Right? 2 ion. Remember, ion part is there at the end. Ion mean triple bond, but where do you find it? Second carbon start triple bond. Second carbon start triple bond. Between second and third, there is triple bond. Then we complete with hydrogen. CH3, second just C, third just C, fourth just C. Here, no more hydrogen because valence is satisfied already. Last carbon, you have CH3, 3 hydrogen. So this is the correct structure for fifth one. Got it? What else? Shall we do one more? I mean, seventh one? In the case of seventh one, yeah, whatever it is, you go to this one. Seventh one, pen. No, seventh one, pent, yeah. Seventh one, pent. Pent mean 5. 1, 2, 3, 4, 5. Yeah, number it. 1, 2, 3, 4, 5. Go to substituent for ethyl. Fourth position, you have ethyl group. This is the fourth position. Ethyl means C2H5. Or you can write it like CH2CH3. Then third place, you have iodo part. Third place, you have iodo. Iodo mean ion. That's all, the substitute one. Then what are the other numbers and everything? You see, then you have 4 ene. Ene mean double bond. Both carbons start double bond. Next on 2 on. There is another 2 on. Means second carbon has the functional group ketone. Ketone means C double bond only. Then everything I completed. Everything I represented given in the name. Thereafter hydrogen. CH3, second carbon 4 satisfied. Then third carbon should have 1 hydrogen. Like this. Fourth carbon valence is satisfied. Fifth carbon, there should be 2 hydrogen. So this is the structure for name given in seventh one.
Got it. That's the way we have. Shall we go to fifth one directly? Fifth one, it's given following names are not according to IUPAC nomenclature. Not according to IUPAC nomenclature, right? It's not according to IUPAC nomenclature. Indicate the error in the names and write the correct IUPAC name. So many things should be done. There is a hint. First, write the structure as per the name given and then assign the name according to IUPAC rule. This is a good thing to practice. Yeah, what to do? First, since the name is given, it's okay whether it is correct or wrong. Just try to get the structure. Pent mean 5. Then we number it like number 1, number 2, number 3, number 4, number 5. Hurry. Then it's given 4 iron. Iron mean triple. Ne? Then fourth carbon atom starts triple bond. That's the case. Hurry. This is the structure given. We complete then valency by adding hydrogen, CH3, CH2, CH3. So this is the structure we end up. Don't you see a problem here? I mean, name this compound again. But once you name this compound again, maybe you notice the problem. Here the numbering is the problem. You see, triple bond should have the priority. Since triple bond should have priority, it should be 1, 2, 3, 4, 5. Got it? That's the correct numbering. According to that numbering, no substituent 5, then it's pent. And triple bond is in first carbon, then 1 ion. So that's the problem. I mean, it's given pent 4 ion. That's wrong. What is correct one? Pent 1 ion. That's what you asked to do in fifth case. Although the name is wrong, we can get the structure. From the structure, we can identify the problem finally. I take one more, not one more. Let's take like what? Sixth one? According to the name given in the sixth one, you see it's first we go to pent part. Again, pent mean 5. We take 5. 1, 2, 3, 4, 5. Then number it. You can select any direction. Then I take it like this: 1, 2, 3, 4, 5. Then complete the other. It's given 2 in. 2 in. 2 in means what? Second carbon atom start double bond. Hurry. Next is given 4 on. 4 on. On means what? Ketone. Then fourth carbon has ketone part. Then complete the other valency. This has 1 more hydrogen. This has 1 more hydrogen. And this has 3 hydrogen. This is the structure we get. Now again, I ask you to name this correctly. As you can see here, again, you will notice sometime the problem. What's the problem? Problem is numbering. Don't you see that? When you number, you see the functional group ketone part, functional group ketone, but here you get the number 4. But number it from this side: 1, 2, 3, 4, 5. Look at this. Number 2 goes to the functional group. Then you have two options, number 2 or number 4. Lowest possible number 2 is the correct one. So according to that, the name will be like, there is no substituent. We take directly the root name or stem name. There are 5 carbon, then it should be pent. Next, the suffix due to double triple. Now the correct numbering is red one. This one is red one is the correct numbering. According to that, it's third carbon start triple bond. Not triple bond, double bond. Therefore, it should be 3 in. 3 in. But here you see 2 in, here 3 in. Someone say, no, it is wrong. But no, before in, we give the priority to own. Here 4 own. But according to this, what we have? 2 own. Then you can see the correct one. Before in, we give the priority to own, functional group. You see, 4 own, 2 own. Which one is correct? 2 own is correct. So this is what you have to do in question number 5. But I take one more. Then Esther, we couldn't do anything regarding Esther. So I take 9th one. 9th one is an Esther. Let's see. First, what should I do? Go to this part. I mean, in Esther, you have C double bond O. Then this side you have one R group, let's say R dash. This side you have another R group, let's say R or something. There are 2 R groups. Then in Esther, I told you, then first we write the isolated one, means which is separated from oxygen. I hope you remember that. That part is ethyl, 2 carbon atom. It's clear. But next main part is this one, pent. Pent mean 5. Okay, we draw 5. In Esther, you remember numbering always number 1, number 2, number 3, number 4, number 5. And first carbon has this C double bond OO part. Then since isolated one ethyl group, it is separated from oxygen. So it should be ethyl here, C2H5. Hurry. Now, fifth one has hydroxy part. Fifth one has hydroxy part, means this one. Third part, you have cyano. Third one, you have cyano. Cyano means CN. Next, you have, I think you notice it, 2 in. You see, in. Oh, I can, if it is not clear, you can write it like this. 2 pentene can be written like pent. What? 2 enoate. Enoate. We can write it in this manner also. Right? So either way, you should be able to manage it, right? Pent 2 in. Pent 2 in. 2 in. Second carbon starts double bond. So this is where you have double bond. Ethyl 5-hydroxy cyanoentenoate. Hurry. Then I complete other valencies. There should be 2 hydrogen here. 4. There should be 2 hydrogen. H and H here, right? Here no hydrogen. Here there should be 1 hydrogen. So this is your structure. Hurry. But what is the problem? Sometimes just look at this, you don't see the problem. Then my advice is name it again. Forget this name. Name it again. Hurry. I follow this order. I identify this as the isolated one. Then we write the name of that. Okay. Ethyl. Leave a space. Sorry. Then this is your main carbon chain. I mean 1, 2, 3, 4. This one is the main carbon chain. Okay. No problem. Then this is substituent. This is substituent. Right. The name of this CN group is 3-cyano. Okay. Name of this one is 5-hydroxy. Okay. Then which one is written first? 5-hydroxy or 3-cyano? Which one is written first? Then alphabetical order, it should be C, not H. That's the problem here. In the name here, you see 5-hydroxy before cyano. It can't be alphabetical order. Everyone remember that one? Then it should be 3 cyano. After that, it should be 5-hydroxy. Ethyl 3-cyano 5-hydroxy. Right. Then the root name. There are 5 unsaturated. Therefore, you should write just pent, not pentan. Next, suffix due to double bond. It should be 2-ene. Sorry. Next, what? O8, ne? But here no space. Therefore, I write it here. O8. No space between E and O8. 2-ene-O8. Or you can take 2 out, 2-pentene-O8. Everything okay, but the problem is this order. 5-hydroxy, 3-cyano, then cyano should be here, hydroxy should be here. That's the problem. Got it? Okay, then these are some examples. I mean, I showed you how to analyze the questions under all these 5 questions. With that knowledge, I think you can manage the other. I'm going to now discuss one more past paper, 1 or 2 past paper questions. Let's talk about 2 past paper questions. I take A-level 2021 and I take A-level 2020. Let's do 3, eh? And I take even A-level 2019. I'll do screen sharing, then you can see that one. I hope you can see this question. It is 2021 paper, MCQ 5th one. 5th MCQ 2021. Right. What is the UPAC name of the following compound? That's the question given. Then you should first identify the class. What is the class? You see, you have alcohol group, OH group. That's the functional group. Therefore, this should be definitely alcohol. Alcohol mean, you know, all should be at the end. All should be at the end. Now look at the answers. In the case of past paper question, no need to name it completely and then check the answer. It's time wasting. Follow the steps one by one and then remove the other. You see, final one, amine, ene. Can these be the answers? No, it can't be. 5th one wrong, 4th one wrong, 3rd one wrong. Why? We identify functional group as OH. It's alcohol. Then at the end, there should be all. Then next thing, identify the main carbon chain. That's the next part. Okay, I try to identify main carbon chain. OH should be there. Because of that, I should definitely start from this carbon and come to this junction. But then it's very clear we should go up because double bond is there. This is your main carbon chain. Then what are the substituent? This one is substituent. This NH2 group is also substituent. Next, we number it. Once we number it, what do we have? Let's see. This is, someone can start this 1, 2, 3, 4, 5. Someone can start from this side, other side. So other side mean yeah, this side. 1, 2, 3, 4, 5. Then you see same number for the functional group. If you get the same number for the functional group, I ask you to give the priority to double bond or triple bond. Yes, double bond available. In the case of double bond, you have number 1 for the double bond or number 5 for the number. Okay, then two option 1, 5. Which one is correct? Then definitely blue one is correct. Ne? Blue one is correct. So you can easily ignore red nomenclature number. Blue one is the correct one. Then NH2 group is substituent. I told you that should be 5 amino. Ne? Fifth carbon you have amino part, so it should be 5 amino. Where do you find 5 amino? This is where you find 5 amino. According to that, you see first one is wrong. Then what is correct one? Second one is the correct answer. So I hope you notice that easy method. Do not name it correctly and then check the final answers. It's time wasting. Follow the steps one by one. After one step, check the answers. Remove the wrong one. Next, follow the other step. Check the answers. Remove the other one. So most probably in the second step or third step, you end up with the correct answer. Therefore, it is definitely time wasting to name it completely and then find the answer. Okay, that is 2021 question. This is 2021. The previous one, 2021. This is A-level 2020. A-level 2020, fifth question. MCQs. Again, right. Follow the order. Identify the class. You see OH group ketone part is there, but ketone high priority. So we identify this as ketone. Then the last suffix should be on. Last one should be on. According to that, you can cancel 4, 5. Because in 4, 5 you have all. Can't be. Should be definitely 1, 2, 3. Next, number it. From the numbering, I think, yeah, let's number it. Once you number it, one can number it from this side. 1, 2, 3, 4, 5. Oh, one can number it from the other side. It's number 1, number 2, number 3, number 4, number 5. These are substituent. OH substituent, CH3 substituent, Br substituent. But again, we have problem. I mean, number 3, same number comes to the functional group. Then what do we do? Then go to the other priority. It's double, triple. Then it's very clear. In the case of blue, you see number 1 goes to double bond. In the case of green, number 5 goes to double. Number 4 goes to double bond. 1 no 4. Easy option. So definitely it's 1. So green, red one is the blue one is the correct number. Then what are the names of substituents you have? Br is there. It should be 1 bromo. Then check the answers. Then you can easily cancel the second one because it is 5 bromo. It can't be 1 bromo. Then look at the option. I mean, you have. Then there are two options. Option 1 and option 3. Here, what is the problem? I mean, the difference. One has methyl, other has hydroxy. Then alphabetical order. Then out of M and H, which one is correct? I mean, H should be before M. So because of that, you identify Then first one wrong. Then what's the correct one? Correct one should be third one. Correct one should be the third one because of the alphabetical order. That is 2020. Let's move to 2019. Fourth MCQ. Identify the class. You know, in most of the past papers, they have given ketone part. I know the problem. The problem is once you have ketone alcohol amine, sometimes you can't then identify which one is having high priority. So it's ketone. Right. Then OH is substituent, NH2 substituent. Numbering. Numbering, one can start from this end 1, 2, 3, 4, 5. One can start from the other end. It's 1, 2, 3, 4, 5. It's very clear. For the functional group, number 2 or number 4, those are the two options available. Easy option 2, 4. Definitely it is 2. Then correct number in the green one. It should be 2 on. Since it's ketone, it should be 2 on at the end. Check it. 2 on. Or 2 simply on. Then it is very clear. You can cancel first one because amine. We can cancel second one because ane. We can cancel fifth one because all. Got it? But once you go to 3 and 4, it has both 2 pentanone, 2 pentanone. Therefore, you should keep it. But the problem, then you can identify it. Why? Here amino first. Here hydroxy first. Alphabetical order. Amino should be first. Therefore, fourth one can't be. So what's the correct one? Correct one is third one. You see how easy to get the answer? You are given 2 minutes for this one, but you don't need 2 minutes. Ne? Right. So likewise, then you can practice the other past paper questions also. And if you have any doubt, you can just contact me and then clear your doubts. Right. Then I think this is enough for the organic nomenclature part. Right. Then shall we end this live because no need to show my face again. So I'm going to stop it here because we completed the nomenclature, the theory part, plus we discussed the questions also. For the other questions, there are key answers. Those who want key answers, then drop me WhatsApp message. I can share answers with you. Okay. Right. Then we will meet again another live stream on the chemical and physical properties of organic compounds. Until then, bye bye. Good night.